Okay. I had a few questions here that came in, and I just wanted to address them. So these are there's four questions here, so I'm going to just work through them. The first one here, as you can see, says the doctor orders dobutamine 4 micrograms per kilogram per minute IV infusion. Patient weighs 198 pounds, and you are supplied with a bag of dobutamine that reads 250 milligrams per 250 ml. How many milliliters per hour will you administer? Okay, so with this question, one of the things we have to do is we have to account for the patient's weight. This is a weight-based problem, so we have to account for the patient's weight, the weight-based problem. We need to convert pounds to kilograms, and then we're going to convert once we get to micrograms, we have to convert that to milligrams. We have to convert minutes to hours, and then we'll have to convert milligrams to milliliters, and we're going to do that all here in a second. So first things first, we need to convert the patient's weight in pounds to kilograms. So you're going to do that just simply by dividing by 2.2. So 198 divided by 2.2, I believe, is 90, but let's plug it in real quick. Divided by 2.2 is going to be 90 kilograms. Now that we have the patient's weight in kilograms, we're going to multiply by the 4 micrograms per kilogram per minute. Okay. Now, if I was going to do this dimensional analysis wise, I'll show that in a second, but really for this initial step, we're just trying to get rid of kilograms. So everything's set up fine. So you don't need to change anything at this point, mainly because I didn't give myself enough room to do it. So 360 micrograms per minute is what we have here. Now, at this point, you can convert minutes to hours, because you're going to have to do that anyway, since the question is asking for what is this in hours. So if you're going to do that, all you do is multiply this number by 60 minutes over 1 hour, which is not a bad idea to do right now anyways. So 360 times 60 is going to be some big number. Okay, it's going to be 21,600. That's micrograms per hour. We're going to do one more conversion. The next conversion we're going to do is we're going to convert micrograms to milligrams. The reason we're doing that is because your available is in milligrams, your order is in micrograms. They both need to be the same unit. So what we're going to do is we're just going to convert micrograms to milligrams. I want milligrams. I don't want micrograms. Okay, so in 1 milligram, there's 1,000 micrograms. And so what that's going to do is now we're going to be in milligrams per hour, which is exactly where we want to be. So 21,600 divided by 1,000, and we're going to have 21.6. That's going to be milligrams per hour. The final step here is we just need to go from milligrams and convert milligrams to milliliters. So our next conversion is going to be taking what I have available, the 250 milligrams and the 250 ml. Now, with that, they just cancel out. And so our answer is going to be 21.6 milliliters per hour. Okay, so it's the same as it was. So this didn't really factor in. We just needed that. So if like this were 500 milliliters and this was 125 milligrams, then we would want to account, and that would obviously change the answer. So 21.6 milliliters per hour, and that's what you would plug into the infusion pump. Okay, next question. The pharmacy has prepared a solution of 50 units of regular insulin, 500 milliliters of normal saline. Order is to infuse 5 units regular insulin per hour. What would be the rate to infuse to set the pump in milliliters per hour in order to infuse 5 units of insulin per hour? So basically, we just restated the units per hour twice in this question. So what is really being asked here is we want to go from units per hour and we want to convert that to milliliter per hour. Okay. So that's like where we're going with all this. So a lot of times with dimensional analysis, the question is, where are we starting and where are we trying to get to? And then it's just kind of like filling in the blanks as we kind of go along. So step one is we know what the units per hour is because they tell us it's 5 units per hour. Okay, so I'm just going to write the 5 units per hour. Now I need a way to get from units per hour to milliliters per hour. And so what I need to do is I need to get rid of units and I need to convert it to milliliters. So do I have something that can help me do that? Well, yes. That's like the whole, that's what's nice about having IV bags, is because all the IV bag, they told us how to get this information. We have an IV bag that contains 50 units of insulin and it's 500 milliliters of normal saline. So that's actually where we get. So our IV bag, and I'm just going to kind of draw a picture here. This is our, our IV bag. There's 50 units of insulin in 500 milliliters in that bag there. So they're just together. Okay. So all I do is I plug in the volume for the saline and then the units for the insulin. And then if I've set everything else right, when I cancel out units, I'll be left with what I'm looking for, which is milliliters per hour. So then I just take my calculator, 5 times 500, which is 2,500, and then divide by 50, and I will get 50 milliliters per hour. And that's how we solve that question. So that was number 2. I have 2 more here. Number 3 says the provider ordered 60 milliequivalents of potassium chloride IV to be given over 4 hours. The bag contains 100 milliequivalents in 1 liter of normal saline. At what rate should the nurse set the pump? So when we say the pump, we're usually talking about milliliters per hour. Okay. And so we're starting off with, this just looks different because now we have something that seems unusual. You have this MEQ, which just means milli equivalents. So don't get hung up on what that means. And so you're going to set this up almost exactly the same way as the previous one we did. So it's basically giving you a rate of, and what it's actually asking is, how do I go from milliequivalents per hour to milliliters per hour? And you may be wondering, well, how did I know that? Well, I've honestly been doing this for so long. I know how to figure these things out. And I'm just asking myself that question, what is this asking me to do? It's asking me to take this quantity over this time and then convert it to a different quantity over time. And that's what I'm using. So just if you're wondering where that is, but if you practice these and work these out and you handwrite it on a regular basis, you too will get the same or similar answers as you continue to practice. So we have the 60 milliequivalents, 4 hours. Okay, because that's what it told me. Then my conversion is I need to go from milliequivalents to milliliters. Now it says we have 1 liter here. We know that 1 liter is what? 1,000 milliliters. And then you can see we have 100 milli equivalents. So all I'm going to do is, well, first of all, I know I've set this up right because I can eliminate milli equivalents. Good riddance, right? Because you don't even know what those are. And let's do 60 times 1,000. And you get 60,000 divided by 4 divided by 100. And you get 150 milliliters per hour. Okay. So notice what I did is I multiplied across the top and then I divided by the numbers in the bottom. You could have also did 60 times 1,000, got 60,000 divided by 400, and you would have came out with the same answer. All right. Last question here. We have Phenytoin comes from the pharmacy as an IV solution of 500 milligrams per 100 ml. A loading dose of 1,000 milligrams has been ordered to be delivered at 40 milligrams per minute. How many minutes will it take to give the loading dose? So what we're going to do is we just need to know how many minutes it's going to take to get to deliver 1,000 milligrams at 40 milligrams per minute. So there's actually extra information here. This 500 milligram and 100 ml really isn't telling me anything as far as solving this equation, because I just want to know the 1,000 milligrams. Now, if it had said, if it had asked this and said this was milliliters, then we might need to do some converting. But because my my flow rate is already in milligrams per minute, and how many minutes will it take to get the loading dose, we're just going to do this. We're going to take what we've been ordered, the 1,000 milligrams, as the loading dose. We don't want milligrams, we want minutes. Can I convert milligrams to minutes? And the answer to that is yeah, 40 milligrams per 1 minute. That's the rate. So you just multiply across the top, divide by a bottom. So 1,000 divided by 40, it will take 25 minutes to get to our loading dose. So sometimes these questions give you extra information that you don't need in order to answer the question. It could have also said that a loading dose for your 217-pound patient has been ordered, but if it tells you specifically what it wants, you don't need to account for the weight. If you wanted to account for a weight, you'd say 1,000 milligrams per kilogram or something to that effect. So I hope you find that helpful. And if you have any other questions, let me know.